Chapter 1. Young Albert. Albert Einstein was born on March 14, 1879, in Ulm, a small city in Germany, into a Jewish family. His father, Hermann Einstein, was an engineer and entrepreneur, while his mother, Pauline Einstein, was a homemaker with a love for music. When Albert was just a year old, his family moved to Munich, where his father and uncle started an electrical engineering company. Albert was a quiet and introverted child, leading his family to worry about his development. He didn't start speaking full sentences until he was around 4 years old, and even then, he preferred to think deeply before speaking. This habit of slow, deliberate thought stayed with him throughout his life. At the age of 5, Albert had an experience that profoundly shaped his thinking. His father gave him a magnetic compass. Albert was mesmerized by how the needle always pointed north, no matter how he turned it. He became obsessed with understanding the invisible forces that control the needle, sparking his lifelong fascination with the mysteries of the universe. Albert's early schooling wasn't easy. He attended a strict school in Munich, where teachers valued obedience and rote learning. Albert disliked this rigid system and often clashed with his teachers. He was curious and independent, preferring to explore his own interests rather than follow the standard curriculum. Despite this, he excelled in mathematics and had a natural talent for problem-solving. At home, Albert's mother encouraged his love of music, teaching him to play the violin, a skill he continued to enjoy throughout his life. His father and uncle introduced him to math and science, giving him books and puzzles to challenge his mind. By the time he was 12 years old, Albert had already taught himself Euclidean geometry and was exploring advanced topics in algebra and calculus. Chapter 2. The Path to Physics. In 1894, when Albert was 15, his family moved to Italy for business reasons. Albert stayed behind to finish school in Germany, but he was unhappy and eventually dropped out, claiming he was suffering from illness. He rejoined his family in Italy, where he spent a year reading and studying on his own, free from the constraints of traditional schooling. Albert decided he wanted to become a physicist, but first, he needed to complete his education. In 1896, he enrolled in the Swiss Federal Polytechnic School in Zurich. To get in, he had to pass an entrance exam. Although he excelled in math and physics, he performed poorly in other subjects like literature and languages. Despite this, he was admitted to the school, where he began studying physics and mathematics. At the Polytechnic, Albert's professors recognized his exceptional talent, but his independent and sometimes rebellious nature meant he wasn't always the best student in class. He often skipped lectures, preferring to study on his own or discuss ideas with friends. One of these friends was Mileva Marek, a fellow physics student who later became his first wife. After graduating in 1900, Albert faced significant challenges. He couldn't find a teaching job because his professors didn't give him strong recommendations. He spent 2 difficult years looking for work before finally landing a job as a patent clerk at the Swiss Patent Office in Bern in 1902. This job involved reviewing applications for new inventions, and although it wasn't related to physics, it provided Albert with a stable income and plenty of free time to work on his own ideas. Chapter 3. The Breakthrough Year. The year 1905 is often referred to as Einstein's Annus Mirabilis, or Miracle Year, because he published 4 groundbreaking papers that forever changed the field of physics. One of these papers explained the photoelectric effect, showing that light is made up of tiny particles called photons. This discovery challenged the traditional wave theory of light and became one of the key foundations of quantum mechanics. For this work, Einstein was awarded the Nobel Prize in Physics in 1921. Another paper introduced the special theory of relativity, which revolutionized our understanding of space and time. Einstein proposed that the laws of physics are the same for all observers, no matter how fast they are moving, and that time and space are not absolute but relative. Perhaps the most famous result from this work was the equation E equals mc squared, which showed the relationship between energy, E, mass, m, and the speed of light, c. This equation demonstrated that even a small amount of mass could be converted into a tremendous amount of energy, laying the groundwork for nuclear energy. These papers, along with his work on Brownian motion, established Einstein as one of the leading scientists of his time and laid the foundation for modern physics. Chapter 4. Einstein and the General Theory of Relativity. In 1915, Einstein completed his General Theory of Relativity, which expanded on his earlier work on special relativity. This theory introduced a completely new way of understanding gravity. Instead of thinking of gravity as a force between 2 objects, Einstein proposed that massive objects, like stars and planets, bend the fabric of space and time around them. This bending creates what we experience as gravity. Einstein's theory was difficult to prove until 1919, when a team of astronomers observed a solar eclipse. During the eclipse, they measured the bending of starlight around the sun, confirming Einstein's predictions. This discovery made Einstein a global celebrity. Newspapers around the world hailed him as a genius who had unlocked the secrets of the universe. Chapter 5: Einstein's later years. In 1933, Einstein emigrated to the United States to escape the rise of the Nazis in Germany. He took a position at the Institute for Advanced Study in Princeton, New Jersey, where he continued his research. During World War II, Einstein learned that Germany was working on developing an atomic bomb. He co-signed a letter to President Franklin D. Roosevelt, urging the U.S. to begin its own research. This letter led to the creation of the Manhattan Project, which developed the first nuclear weapons. Although Einstein played no direct role in the project, he later expressed deep regret for his involvement, becoming a vocal advocate for peace and the abolition of nuclear weapons. Einstein spent his later years working on a unified field theory, an ambitious attempt to combine all the forces of nature into a single theory. Although he was never able to complete this work, his efforts inspired future generations of physicists. Chapter 6: Einstein's Legacy. Albert Einstein passed away on April 18, 1955, at the age of 76. He left behind a legacy that continues to influence science, technology, and society. His theories of relativity transformed our understanding of the universe, while his work on quantum mechanics laid the foundation for many modern technologies, including lasers, semiconductors, and even GPS systems. Beyond his scientific achievements, Einstein was a symbol of intellectual curiosity and humanitarian values. He believed in the power of imagination and once said, "Imagination is more important than knowledge." Today, Einstein's name is synonymous with genius, and his contributions to science continue to inspire people around the world. His life is a testament to the power of curiosity, perseverance, and the belief that one person's ideas can change the world. Thanks for watching the video.